Thanks for tuning in to today's mini lesson on something you actually already know, even if you don't know it by name. And I'm going to show you already know exactly what we're doing by doing a couple practice problems. So go ahead and solve this problem for me. Yeah, 5 times 1. What does 5 times 1 equal? This should be pretty automatic by now. It's 5. 5 times 1 equals 5. We take a number, we multiply it by 1, and lo and behold, we get the exact same number. Now let's do one that's a little bit more difficult. 10 times 1. What does that equal? Yep, 10. Same concept. A number, multiply by 1, we get the same number. Great. We can even be silly here and do a happy face, multiply that by 1, and we get a happy face. Same concept. And what we're doing here, multiplying by 1, is a concept that we're actually going to use in this class, but also as we get to algebra, called the multiplicative identity. Now what we just did, we just used the multiplicative identity by multiplying by 1. That's exactly what it is. Multiplying by 1 is using the multiplicative identity. However, today we're going to stretch that a little bit by using the multiplicative identity to create equivalent fractions. And we're going to do that by using this giant 1 over here to the right. Okay? But first we have to realize that we're going to do this by starting with a fraction. For example, the 2/3. We're going to start with a fraction. Then we're going to multiply that fraction by another fraction that's equivalent to 1. Hence why we have the big 1. We're going to multiply by another fraction that's equivalent to 1. And again, just to refresh, what does equivalent mean? Equivalent means the same. It means the same thing as 1. Okay, and we notice here in our giant 1, they have 2 divided by 2. How is that equal to 1? Well, let's look at a picture. Split it into 2 parts. This entire piece equals 1 whole. So if we color in 2 out of 2, do we have 1 whole? Absolutely. And that's going to equal 4/6. Okay, well let's look and see if this works. What's 2 times 2? 4. Great. What's 3 times 2? 6. Great. So ultimately, 4/6 is equivalent or equal to 2/3. Now, 2/3 and 4/6 don't look the same numerically, but if we set them up using fraction cubes, it might be a little bit more clear to you why they are exactly the same number. So we have 2 fraction cubes that are the same. I'm going to break those up into different equal parts based upon the fractions given. So the 2/3 when I'm going to start in the first one, I'm going to break it up into 3 equal parts. Why? Because my denominator represents the total number of equal parts, which in this case is 3. For my second one, I'm going to make it into 6 equal parts. Why? Because again, the denominator represents, for me, the total number of parts. You'll notice here we have 1, 2, 3, 4, 5, 6. Now, if you've drawn this on the paper that you have next to you, that's great. If not, I'd go ahead and try to draw this as best you can. Now we're going to do the shading, which is the fun part. So, 2/3. Well, we have 2 of our thirds colored in. Great. On the second one, we have 4. 1, 2, 3, 4 colored in. Now, if you can't see right now that this is these are actually the exact same amounts, let me try to make it a little bit more clear by making this a little bit darker. So if we were to shade this in, we would have here a certain amount, and we would have here a certain amount. Are those amounts the exact same? Yes, yes indeed, they are. So we can put a check and a check. We have equivalent fractions. Great. We're going to move on to one example just to test to see if we know what we're talking about. So I'm going to go ahead and clear this page. And as I write this, go ahead and write it on your paper and try it yourself. So we are going to, the goal here is to create an equivalent, which again means the same, create an equivalent fraction. Okay? So we're going to do that with this one problem here. So go ahead and create an equivalent fraction to 3/4 any way you know how. I'm going to go ahead and I'm going to give you about 15 seconds to do this. Okay, so for starters, what we want to do is we want to draw our giant 1. Because our giant 1 is going to remind us that to find an equivalent fraction, all we're doing is multiplying by 1, the multiplicative identity. But this 1 has to be in the form of a fraction that's equivalent to 1 or equal to 1. So I'm going to choose a small number so it's easy for me to multiply. I'm going to choose 3/3. Now, could you have chosen 4/4? Sure. Could you have chosen 10/10? Absolutely. You could have chosen any number over itself, and this would have worked out. You would have had an equivalent fraction. So I'm going to do this. 3 times 3 is 9. 4 times 3 is 12. Therefore, 9/12 and 3/4 are equivalent fractions. Thanks for tuning in to today's math lesson. We'll have another tomorrow.